We're taking a look at Clojure. Here on Answer Everywhere, we'll look at its source code. It runs on the JVM, but is it written in Java or is it written in Clojure? We'll find out. Hollywood stars. Okay, so 57.6% Java, 41.9% Clojure. So mostly Java. That's not the least bit surprising. You might expect it to be more self-hosting, but hey, what do you know? So I've never used Clojure. Have you used Clojure? Have you ever gotten Clojure? So I assume this is named after the Clojure programming thing. Programming doohickey. Abstraction. In programming languages, a closure, also lexical closure or function closure, is a technique for implementing lexically scoped name binding in a language with first-class functions. Operationally, a closure is a record storing a function, together with an environment. So the environment is essentially the environment in which the function is to be evaluated. Environment is a mapping associating each free variable of the function to variables that are used locally, but defined in an enclosing scope, with the value or reference to which the name was bound when the closure was created. Unlike a plain function, a closure allows the function to access those captured variables through the closure's copies of their values or references, even when the function is invoked outside their scope. All right, good stuff. So let's look at how it's implemented. We are near the end of the old regime where I took a bunch of requests and I'm plowing through that backlog. We're going to do 30 minutes time boxed for each of the repos today. And then after the backlog is done, we will enter the new regime in which the focus will be, I'll still take requests. We'll firm up how the requests happen so that there's less to rate limit things and have more of a curated approach where a significant part of the curation is done by the community. And then that will be balanced with building things, including building up the Holy Hedge Fund and the Cult of Pythagoras and the code that I've been working on. All right, so let's set a timer. And let's look into Clojure. I'm on the GitHub repo. I think this is the real live place where this lives. And what? Okay, so we have code gen. Code gen might be important. I don't know how much code gen they do. We also have tests. I'm kind of feeling like looking at tests, and then we have doc, whatever pprint is. I'm going to guess this documentation is mostly like code-based documentation, and maybe that's not my thing. And in source, we have assembly, clj/closure, jvm/closure, resources/closure, and script. I'm guessing resources is like static assets. So, and I will assume, based on Java's naming convention, that jvm/closure is the Java implementation. clj/closure is once we've bootstrapped on the JVM or however we're doing it, that should be the stuff in here. And then we have assembly, which might be just super optimized routines. And let me just verify, but I believe Clojure is a Lisp. Let's get the basics right. It's a Lisp programming language, a functional dialect. I don't know what a non-functional dialect of Lisp is, but okay, so that's source. And then in test, we have Clojure in Java. What's more important? Clojure, test, compilation, reflector. So there's some amount of reflection, test, dispatch. There's not a lot of Java tests, at least in there. A few in the Clojure/test. Let's see what's in Clojure. Test, Clojure, and helper. Cloj. We have many more tests in Clojure, which makes sense. including gen class, annotations, compilation, Java, preprint. Preprint must be pretty print, right? Protocols. Examples, hash collisions, more examples. Should we look at examples? I guess the file name is Clojure. This is definitely Lisp. So the way Lisp works is the head of the list is the it's like the function. I don't know what I forget what the terms are, but the head of the list is the function, and then everything after it is data, and it's just it's like an S expression. If we're reading Lisp, let's make sure that we have just a general understanding of oh, this is the speech thingamajig. It's essentially the lambda calculus, right? Okay. Trying to see if we can get a good description of. We have control structures, evaluation, and the read eval print loop. Lisp languages are okay. Maybe that's not the entry point I thought it was. List structure of programming code. Exploitation by macros and compilers. A fundamental distinction between Lisp and other languages is that in Lisp, the textual representation of a program is simply a human-readable description of the same internal data structures, linked lists, symbols, number, characters, etc., as would be used by the underlying Lisp system. Lisp uses this to implement a very powerful macro system. Like other macro languages, such as the one defined by the C preprocessor, for the C, Objective-C, and C++ programming languages, a macro returns code that can then be compiled. However, unlike C preprocessor macros, the macros are Lisp functions, and so can exploit the full power of Lisp. Okay, so we've looked at Emacs Lisp before. These are just tests. That's not so interesting. So let's go into how this is defined. So in the Java folder, we have ASM, which I assume is assembly, the Java API. I don't know what that is, lang, and main. I'm going to guess lang is the place to be. We'll look at these other folders as well. And we will open up this Clojure directory too. And this is where most of the, at least we have more files. We saw that there's more actual Java code written. That could be a reflection of the fact that Java is more verbose, rather than a reflection of the fact that it's mostly Java. And in core, we have some stuff. We'll open core, we'll open Java. I refuse to open preprint. REPL might be interesting. We'll open core.Kulj. I don't know what instant is. Maybe we'll look at instant. Maybe we'll look at main and math. And parallel might be mildly interesting. String, is that interesting? I'm not sure. Stack trace could be amusing. Walk, I'm going to guess is walking not only Lisp, but traversing other kind of data structures. And we have zip. And what's an assembly? Assembly, I guess, is like assembling maybe the packaging. I'm being told that YouTube is not getting enough data. Let me see if I can back down this stream latency or anything. No, I don't know. I don't think I'm streaming at like higher than normal. I think it'll be fine. I'm going to repost the videos anyway. Okay, slim. So this is just some XML. This is not an assembly language, I guess. What did I just look at? Distribution or slim? That's slim. And then distribution, I guess this is describing like parts of the source code, I guess, to distribute. So we can safely ignore that. That's good. Now we have to choose in our remaining time, which is about 23 minutes, to split between Clojure and JVM. I have a feeling if we start looking at Clojure, we will look at it forever. And we will forget. It's kind of hard when you're in one programming language, it's kind of hard to see the boundary to the language it's implemented in often. It's easier to see where the implementing language calls the newer language. So for that reason, maybe we'll just at least take a look at what's in the Java folders. I is probably interface, assuming they're just using this naming convention. We have a bunch of interfaces like proxy, record, reduce, persistent stack, persistent map, lookup, some indexed stuff. I don't know what indexing what. Don't know. Map stuff. Murmur. I don't know what Murmur 3 is. RT, possibly real time. Record iterator, ref.java, seek enumeration, set table, tuple. So these look like a lot of data structures. Function, I guess we probably should look at counted cycle. Maybe we'll look at cycle, compile and compiler, chunked cons. So cons is the Lisp operation that that adds a new element to the list. Do we have a cdr? We don't have a cdr. So we'll open a few of these. In the API, we have just Clojure.java. That might be an interesting entry point. And here's Clojure/asm. We have things like okay, this looks like frame. I'm going to guess this may be a stack frame, a method writer, a method visitor. I guess we'll look at method writer, method visitor. Well, I guess we'll look at handler, a type path, and a type reference and a type. I'm going to guess a path is like possibly like a fully qualified name. There's some annotation stuff, byte vector. Do we care about byte vector? Probably not. Commons. I don't know if this is generator, method, table switch generator. I don't know if these are interesting. I guess we'll open up method just for funsies. All right, and so now we're in code. Cool. And let's just prepare the other window. Should we? No, let's not, because I'll get confused about which window is which. Wonder if there's a quick and easy way to like highlight, to change the coloring of these windows so I can know, so I can like, color them. Okay, so here's function.java. There's nothing. It's a public interface. It has no constraints. Cycle.java. Actually, let's start with, I thought Clojure.java was down here somewhere. Here, let's start with Clojure.java. We get this comment, the copyright comment. This is the package java.api. And we're importing a few things, mainly the function interface, what is a symbol, what's a variable. RT, I guessed before was real time, and it's probably runtime, right? When they say runtime. And then what else do we have? Okay. The Clojure class provides a minimal interface to bootstrap Clojure access from other JVM languages. To bootstrap, the Clojure class provides a minimal interface to bootstrap Clojure access from other JVM languages. So this is not really fundamental to Clojure. This is going to be kind of like a foreign function interface, but restricted to the JVM. Maybe it is interesting. Maybe will tell us a little bit about Clojure. We'll take a quick look at the ability to use Clojure's namespaces to locate an arbitrary blah, blah, blah. A convenience method for reading data using Clojure's EDN reader. I don't know what EDN is, but that's actually not so interesting. This is kind of like just string manipulation, I guess, because the JVM is operating on strings fundamentally, in some sense. So here's Clojure asm frame. Let's see what kind of frame it is. The input and output stack map frames of a basic block. Stack map frames are computed in 2 steps. During the visit of each instruction in method writer, the state of the frame at the end of the current basic block is updated by simulating the action of the instruction on the previous state of this so-called output frame. I don't know how you're going to simulate that. The state of the frame at the end of the current basic block is updated. After all instructions have been visited, a fixed point algorithm is used in method writer to compute the input frame of each basic block, i.e. the stack map frame at the beginning of the basic block. See method writer. Output stack map frames are computed relatively to the input frame of the basic block, which is not yet known when output frames are computed. It is therefore necessary to be able to represent abstract types, such as the type at position X, in the input frame locals, or the type at position X from the top of the input frame stack, or even the type at position X in the input frame with Y more or less array dimensions. This explains the rather complicated type format used in this class explained below. Okay, so this is looking complicated, possibly important, but I think it's going to be difficult to follow this without knowing more about Clojure. So maybe I'll pop that off in its own thing. I doubt we will get to it, but that looks a little bit too technical for where I am, at least in my understanding of what's going on in the code. Let's see what else we have. This is the Clojure window. Let's go back to Java. Is this Java? Okay, so here's method writer. ASM, a very small and fast Java bytecode manipulation framework. Okay, so this is called it ASM. It's really manipulating bytecode, it looks like. So method writer extends method visitor. A method writer is a method visitor that generates a corresponding method info structure as defined in the Java virtual machine specification. So the JVM specification says that you have to have some sort of method info structure, and this is going to comply with that. Just allowing it to run on the JVM, maybe allowing other things to contact it. But that's not something that I really care about. Method visitor, I'm going to guess ASM is all part of the same project, so I'm going to ignore that for now. Chunked cons, is it interesting? I'm not sure. Chunked cons takes an iPersistent map, which is called meta, maybe metadata, and a chunk, which is a thing that implements the chunk interface, and more, which is a sec, maybe some kind of sequence or iterator. We're going to call this super, we're in Java, right? So we're going to call super on the meta thing to call its, what's it called? Initialization function, whatever that's called in Java. Then we're just keeping track of the chunk and the more. And chunked cons is a function that takes in a chunk and some more and calls this. And that just, I guess, produces the chunked cons object. When you call first, we ask for the nth, I guess, element of the list, which is just, and we're asking at n equals 0, so that's the head of the list. Next is going to call, if we have more than one chunk, then we're going to return a new chunked cons, dropping the first. So it's essentially that's like tail, and we're going to call more on that. That's just consuming the first element and getting the what's left, and we're going to return chunked next. And what is, so chunked first just returns chunk. This is like the head of the list. Chunked next returns chunked more dot seek. And presumably seek is like the iterator, the thing that makes it iterate. And what's chunked more? Chunked more returns an iSeek. And if more is null, if underscore more is null, I guess we're at the end. We have the empty list, I think is maybe what that means. And then otherwise we return the list. So that seems to be an implementation of a list. I don't know what makes it chunked. I guess I didn't really get a chunky feeling from it. We have iChunk. Should we find out what iChunk is? iChunk sounds like it's a novel about a person's struggle with weight loss. So iChunk has us drop first and reduce. I don't know why it's called chunk. Seems like pretty regular listy, but maybe it is chunked in some important way. Here's compiler.java. We have a bunch of symbols. Like these are the symbols in the language of Clojure rather than Java. These are things like def, loop, recur, if, let. These will go at the head of our list. So if we see some, let's go back to the Clojure article. Def should define a function. Oh no, defin defines a function. What does def do? I don't know. Do we have a defin? We have emit for deafen. I'm not sure. How about we look up Clojure loop? So loop does seem to be a reserved word, but it's not all caps. So I don't know. Maybe this is the Java side of stuff that's implemented in Clojure, but we'll see. So we have def loop recur. I'm going to guess is a recursion or a recurrence. If case, this is conditional control. Let fn. These should be binding a name to a variable. Do, I'm guessing is a do loop. Quote is quoting treat the following as like a string rather than interpret it. The var, I don't know what the var is, import dot assign def type, etc. We also have try, throw. This is like error handling. Monitor I'm going to assume is the mutual exclusion monitor. And we also have catch and finally. We have also max position arity is 20. I don't know if that means you can only have a 20 arity function. We have things like object type, keyword type, etc. And here's some stuff about local binding. We have this var local end is equal to var.create null set dynamic. It's some dynamic variable, I guess, probably set to null initially. It can be anything. Loop locals, we're calling create. We're not calling passing null to it, but it's a set dynamic. Maybe this is for dynamic typing, keywords, vars, etc. We have things like source. Source is a var intern with a namespace, Clojure.core, etc. Yeah, so this is source code stuff. This is interesting, but we're going to kind of breeze through it. Here's tail call. This will, I guess, check if we're in a tail call. It returns a Boolean, and you pass it in a context. And if the context is c.return, so I guess we're returning, and the method return context, when we dereference it, it's non-null. And if we are in catch finally, if we are not, I guess, in catch finally is probably what this means, then we return true. So we return true if we're not in a catch finally block, and we're returning, and the method return context is non-null. We have a class def_expr, def expression, which extends expression, and it's got things like a var, presumably for holding variables, an init expression, a meta expression, whether init is provided, whether it's dynamic, a source. I guess we're going to keep track of the source in the line and the column. We have this bind root method, void bind root object. This looks like maybe this is essentially generated Java code. This is some definition that we're going to use to generate a Java class somehow. And we'll move along from here, but this is actually interesting, the compiler.java. Maybe we'll come back to it if we have more time, which I don't think we will. Here's compile.java. And maybe this is the thing that just kicks off the compiler. We've got a main function, so it's doing some execution. I'm going to guess we're importing compiler. No, we're not. But what functionality do we have? We just have really main. So maybe this is like a thing that you can run on the command line. Var push thread bindings. I think probably runtime map compile path. So this is the thing that you invoked, I guess, to do the compiling. I don't know why it doesn't import compiler. I guess it doesn't really matter. Maybe runtime has a reference to compiler. And here's cycle. Cycle is probably not so important. This is probably cycle detecting, but if there's a runtime.java, we should look at that. rt.java. We don't have a class level description, but we have Boolean t is defined to be Boolean true, and f is defined to be Boolean false. We've got some default imports, which are commented out. And we've got these intern symbols. I'm not sure if this is interning it means it's an internal symbol. We have things like Boolean, byte, compiler, double. These are common types. Big decimal, runtime exception, security exception, etc. Read, true, false, unknown. And what? It's just a bunch of stuff. So this is definitely the runtime, and it's big. 2,400 lines of code. And we're not going to really be able to make much sense of it. So let's move on to the Clojure code. I'm going to ignore frame. So where do we want to be in Clojure? Let's see. How about core protocol? We don't want protocols reducers. We have about 7 minutes left. Process shell IO. I think those are not going to be fundamental. Reflection, I think is not going to be essential. So REPL just has deps.clj. Clojure REPL deps provides facilities for dynamically modifying the available libraries in the runtime when running the REPL without restarting. Dynamically modifying the available libraries. So this is, so you don't have to restart when you change things. Here's core.clj. This looks like a command line parsing thingamajig. Maybe we're defining some stuff. Maybe this is just notation. Args list. This is like documentation for the function. This function creates a new list containing the items. And added. Maybe this is a version of Clojure. It was added. So what's the function name? List maybe. Okay, so list. And then whatever this is, .clojure lang persistent list creator. So I'm guessing that this line is telling you the like Java method. That's being called. So creator is an I function. So I'm not sure. I guess, does that mean it's not a method? Something. Here's the definition of cons. Returns a new seek. Oh, I guess seek. This is a sequence. I thought it was some sort of iterator, but maybe it's, I don't know. Let's look up Clojure seek. Or let's just look for seek in here. Maybe seek.java. Aseek, iSeek. And iSeek is a persistent collection, a persistent functional sequence interface. iSeeks are immutable variables, i.e. neither first nor rest changes or invalidates the iSeek. Okay, so it has essentially the same. You can get the first, you can get the next, you can get more. More, I'm going to guess, is essentially tail. Next should be the next element, and cons is like adding a thing. So it's kind of like an iterator, except we can manipulate it and we get a new thing back. So it's maybe more like a list, a classic list. So cons is the classic cons. We've got this function star thing. I don't know what that notation means, and I don't know what this pointy nose smiley face is, but we see static cons brackets x seek, and then Clojure lang RT. I guess this is some call to the runtime. We're going to call cons x seek. X seek is the arguments list. So this is, I guess, a list of arguments. And this, whatever this thing is doing, this is essentially allowing us to mix in Java, I think is what's going on here, unless this is a thing that's like reified into Clojure from the Java code in some other in some other library. But, and I don't know what fn star means, as opposed to fn and like dot. Let's ask the AIs. Well, let's ChatGPT. So the following is Clojure code. Why do some entries begin with dot and others with fn star? And how is fn star different from fn? And what does mean the pointy space smiley guy? Entries starting with a dot are likely symbols that refer to existing functions or variables in your current namespace. Okay. Function star is an anonymous function definition with a twist. So it's essentially a lambda. It's similar to function, but with potential performance optimization. Like fn, it creates an unnamed function on the fly. However, fn star might be inlined by the Clojure compiler. Okay, so it might be inlined. Fn is a standard way to define an anonymous function. And this smiley face thing is meta tag is used to attach metadata to Clojure forms. And I guess forms include functions, variables, data structures, and its metadata is additional information. So it's attaching metadata. And what is the metadata? Maybe the arguments. The syntax for attaching metadata is pointy nose key value. For example, pointy nose doc, this function, blah, blah, blah. In your code, you might see other meta tags, but it's okay. So this is what? So doc, this defines a doc, and this defines a static cons. I guess, is that metadata? Why? I don't know. And then here's more. These seem like the main definitions of the like classic Lispy functions. We have sec question mark vector map, a map question mark. I don't know if map has a question mark because it's nullable. Return true, or maybe because it's a Boolean. Return true if X implements I persistent map. And so we're going to have this fn. It's not going to be inlined, I guess. And so the static map question mark and taking X as an argument. And we're going to call instance question mark of Clojure lang I persistent map. So this thing in here, I guess this is Clojure and not Java. So that's probably what was going on up here. Although we should have the ability to call Java methods pretty seamlessly. I've never really used the only JVM languages I've used are Kotlin and Java. I haven't used any of the functional stuff, but now I'm curious, like, what are we importing? We should be able to import the stuff from Java, but it doesn't seem like we're really importing anything. We have this def macro import. EDN you can think of as Clojure's JSON, but better. In particular, extensible. The loop construct is a usual. Yeah. Okay. So the loop is just looping, and the .fn arg syntax is for field member access, but in prefix form. Okay. So the dot is the field accessor dot, like in Java. Thank you, Elsie. That's extremely helpful. So here, I guess we're calling the creator field of the persistent list. Is that the idea? Let's see if there's a persistent. Well, no, that's not going to work. See if we can find dot creator. I don't know. And then that's for metadata. Yeah. So such as provenance, or as seen here, used in compilation generations. Okay, cool. Thank you, Elsie. That's extremely helpful. All right, here's instant.clj. I don't know what this is. Clojure. instant. So this is some namespace annotation. We're going to set warn on reflection, and we have some convenience macros that like this private thing will fail. Throw some sort of, oh no, this is, I guess maybe just the annotation is that it's private, and LC is saying that the some of the times the annotations are used for compilation and generation. So I'm guessing this is to annotate that it's a private message or something along those lines. Yeah, okay. So we have this parse timestamp thing. Maybe instant is like for time stuff. Return a function which constructs an instant by calling constructor after first validating that those arguments are in range and otherwise plausible. So this is calendar timing stuff. I guess instant is maybe a little bit like now. Here's main.clj, top level main function for Clojure, REPL, and scripts. So this is, I guess, for mainly for REPL, which I guess what else would the top level do? We have demunge. Given a string representation of a function class, as in stack trace element returns a readable version. We can root calls, returns the initial calls of an exception or error by peeling off all of its wrappers. That's useful. This should just be basically be a tree walking exercise in Lisp. That's probably a fun thing to look at, but we are going to plow along. We're actually out of time, but let's see if we can see a little bit more. We have with bindings executes a body in the context of a thread local bindings for several vars that often need to be set, like warn on reflection, math context, etc. Seek is the almighty abstraction. Okay. Yeah. Sounds. Thank you. All right. File name x triage. I don't know what x triage returns an analysis of the phase error calls. Okay, so there's a lot of error handling stuff, which I think makes sense for a REPL. And here's this is the definition of the REPL, I believe. Generic, reusable, read eval, print loop by default reads from in, I'm guessing standard in, and writes, or maybe Java in, and writes to out, and prints exception summaries to error. If you use the default read hook, in must either be an instance of line numbering pushback reader, or duplicate its behavior. Blah, 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 blah. Init is a function of no arguments, initializing hook called with bindings. Need prompt, a function of no arguments called before each read eval print except the first. The user will be prompted if it returns true. For example, if we are in and at line starting in and identity is true, then I guess then we will need a prompt. So we have some options. I don't know if these are the arguments to the function. We are defining some stuff here. Cul might be class. Let cul get context loader, thread, current thread. I guess this seems to be getting context from the current thread. And then we're going to, I guess, call the set context loader to something, whatever dynamic context class loader of CL or something along those lines. Here's some more let bindings, I assume. And these are some, I guess these are, it's defining some sort of keys. Perhaps this is a kind of map, I don't know, but init need prompt flush read eval print caught. Or, and then I don't know what keys or means, but we have init need prompt flush read. Read is corresponding to REPL read. Need prompt. This seems to be the like the default definitions of these functions. I guess this is like an empty. There's no initialization hook. This is, I think we recognize this as the what it told us was the default implementation of need prompt. I'm guessing REPL prompt is the default implementation of prompt. Flush with flush. Read is implemented as REPL read. I think that's what's going on there. Then we'll call apply on the hash map options. Or rather, we'll apply, I guess, the function hash map to options. And then do some prompting stuff. And then read eval print. I don't know what's going on here. I don't know where this scope is. Are we still in, have we terminated this bracket? I don't know. I don't think so. This is the problem with Lisp. You have to figure out where all the parentheses end. But this, I'm going to guess, is aligned so that when we do terminate the bracket, it'll be like down here. Or not. Maybe it's here. At any rate, I don't know syntactically what this is. Maybe this is defining the function read-eval print to be a function of no arguments. It's going to try some stuff. What is it going to try? It's going to try to, I assume this is let binding. Let bind read-eval as whatever star read-eval star is. And I guess this is probably trying to get the input. Try read with known, read request prompt, request exit, and maybe throw an error if there's a reader error. Or request prompt, request exit. I don't know what set 3.2, set 2.1, set 1 value is. And then some erroring out, and we might have an exception. And then we have some with binding stuff. So I don't really know enough about Lisp to know what's going on there, but that's some implementation of a read-eval print loop. Timestamp like data is instant. Thank you, LC. And the ... are vectors, i.e. arrays, as opposed to, and have a specialized notation. Function argument. Okay, so the function arguments are provided as vectors. That's interesting. The one I'm looking at are the bindings in the let. In that case, it's assigning a function to the name. Yes. Okay, cool. I think that's, there's a little bit of a delay, but I think you were saying that here, that this read-eval print is being assigned this thing. I don't know what keys or is, but this must be like a dictionary like notation. Not Lisp. Let's look up Clojure. The keys key can be used to further remove duplication. The as and or keywords can be combined into a single destructuring. So it's something about destructuring. Associative destructuring. And then we also have a sequential destructuring. Associative destructuring is similar to sequential destructuring, but applied instead to associative key value structures, including maps, records, vectors, etc. The associative bindings are concerned with concisely extracting values of the key map by type. And so what does OR do? Also allows you to supply, so OR allows you to supply a default value. I don't know why that's not called something more informative than OR. The value for colon OR is a map, where the bound symbol here, category, is bound to the expression category not found. When category is not found in client, it is instead found in the colon OR map and bound to that value instead. So here's the example. Here's where it says OR category not found. And I guess this is where it tries to bind to the original category, perhaps. Something like that. Keys is merely a name using, okay, cool. That's thank you, Elsie. And we're out of time. Let's see if there's anything else we want to see here. Math is always cool. Let's look at sign. Sign returns the sign of an angle. I guess we're just calling math sign maybe in Java. I don't know what math / sign is. So I think we're just calling out to a Java function. That's the nice thing about implementing something on the JVM is you get to call the Java functions. So there should be a sign implementation here. Yeah, okay. Parallel, deprecated wrapper of the fork join library. Okay, so this is deprecated and it's using an underlying Java library, I think. Stack trace is interesting. I think the intuition behind stack traces in something like Clojure or Lisp is that because the structure of the program is the same as the structure of the code, you get a lot of it's easy for scripts and other utilities to understand the structure of the code and to present it back to you in a way that it's clear to you because you wrote the program in the same syntax. So people who work in Lisps, I think, often describe one of the advantages of the being able to debug things and modify things on the fly because of this structural similarities. By similarity, I mean identity. Walk.clj, I guess this was probably some sort of traversal, a generic tree walker with replacement. So I guess we're walking trees in particular. Traverses form an arbitrary data structure. Inner and outer are functions. Okay, so this is going to do some data structure traversal. Zip should be functional zip. A functional hierarchical zipper with navigation, editing, and enumeration. See Hewitt. And definition zipper creates a new zipper structure. We have branch. Branch is a function that given a node returns true if we can have children, even if it currently doesn't. Children is a function that given a branch node returns a seek of all its children. Okay, so where's the implementation? Okay, so branch, children, make node, and root. And then we've got this annotation thing. Zip branch is set to branch. I guess we're maybe annotating with the arguments that were passed in. And then what? And then passing and also root nil. So this is like the maybe the initial case of a recursion. I don't. So these are all arguments. I think these are annotations, if I'm understanding correctly, and these are some new kind of arguments that we're calling. Maybe we're just returning this vector or something. Vector zip, XML zip. A node is just like, I guess, a location in the code. We have this children function, which you call on a location, and if branch question mark of the location, then so if should be if the true case and then the false case. So the false case, we throw an exception, it looks like. And in the true case, we call zip slash children. I guess slash is used here to a kind of namespacing thing. So like zip is the like class or module that we're in children is maybe the function on the we'll call meta on the lock. I guess getting the metadata, and call node on the lock, or create a node out of the lock, perhaps. And that's going to call the zip children function. I don't know how that's different from the function we just looked at, but returns a seek of the children. So this should be some sort of recursive thing. So if we're branching, we should be calling, I guess, zip on both branches. This colon thing, I'm not sure whether we've talked about yet, but I think this is essentially somehow calling zip on both branches somehow. Yeah. Okay. No, I haven't even noticed the typos. So I'm looking at what else he is saying. That is merely a literal textual. Yep. So of the data structures, for example, lists representing the program. You can think of the program as a list or as an express program. As such, you process them exactly as you would with any other instances of such data structure. Yeah, for sure. So we've looked at a couple of Lisps. No, we've looked at a couple of functional languages. We've looked at some Haskell. And so things like zip will be familiar from Haskell. We've looked at Emacs Lisp, which I was also I also don't write Emacs Lisp. I don't write all of the Lisps. So I know just enough Lisp to get by, but I wouldn't be able to like write a program in them. And at some point I should, but I am a big fan of some of the listy functional languages like R and Haskell. And I'm sure Lisp is really cool. My take on, I'll just give you my take. My take is that Lisp is, I believe, essentially an implementation of the untyped lambda calculus. I really like types, and so Haskell is like a typier version of Lisp in a sense. And one of the nice things you can do in Lisp that you can't do in Haskell is because of the untyped nature, you get it's a lot more of a dynamic language like Python, whereas Haskell has more of a rigid structure. And just as a personal preference, I like having the rigid structure to prevent you from doing things. So to make sure that what you're doing is something you always understand. Whereas I find in dynamic languages, there can be kind of like bugs that are harder to track down because of the flexibility. So you probably, once you get really good at it, that's less of an issue. But I'm not sure, for example, like if there are any really huge Lisp databases out there. But surely there are somewhere. Okay, so that's Clojure. That's Clojure for now. We may at some point return to other Lispy stuff. We may at some point return to Clojure, but we'll leave it there for now.